Hello, pre-calculus students. I'm going to give you a video with respect to the newest assignment regarding roots and factors of polynomials, right, which has a focus on types of division, synthetic division and long division. The video will take about 8 to 10 minutes. Before I start with the math, I want to give a plug for what's become one of my favorite books, probably the most meaningful book I've ever read, called The Omnivore's Dilemma. Okay, it's a really wonderful book, very well written, and pretty much it talks all about food, which is kind of a fun and interesting topic that, in my opinion, you don't learn so much about in school. So if you have some free time, sometime over a break or the summer or the weekend, a really excellent book to read that really discusses where a lot of our food comes from, and it kind of forces you to question a lot of what we eat and why we eat it, and it was really a life changer for me, so I'd highly recommend it. All right, back to math. So with this is problem 3 on the newest assignment. There are 3 parts to the problem. First part is to list all of the possible rational roots. All right, not actually define the roots, but just listing out all of the potential rational roots. Another part is to actually find all the factors of the polynomial. All right, and then another part is to find the actual roots. So three parts. All right. I've gone through how to find the possible rational roots in class. Just to remind you, this is for part A. The way we do that, to list all of the sort of the candidates, list all of the possible rational roots. We use what's called the rational root theorem. And we just take factors of the last coefficient and divide them by factors of the first coefficient, and that's how we can find all of the potential rational roots. All right, the reasons for that I'm going to go over in class, if I haven't already done so. But we have factors of 8. We have 1, 2, 4, and 8. Factors of 10, we have 1, 2, and 5. And then we do every possible division combination there. So our possible rational roots would be 1 over 1, which is just, well, plus or minus. 1 over 1 is just 1. 1 over 2, so 1/2. And then 1/5. And then we also have 2 over 1, which is just 2. 2 over 2, which is 1, it's already written. And then 2 over 5, which is not yet recorded. 8 over 1. 8 over 2, which is 4. And then 8 over 5. And then, not sure why I skipped over the 4. I blame the reflection from the window. But 4 over 1 is 4, we already have that. 4 over 2 is 2, we already have that. All we have is 4 over 5. All right? So there are all of these numbers, positive or negative, all of those are the candidates for rational roots of this polynomial. All right? So that's all you have to do. Should be the easiest kind of problem in this part of the unit, just to divide factors of the last coefficient over factors of the first coefficient. Okay? So that's the rational root theorem. Letter B. This part's going to take you the longest. This is where you have to factor the polynomial. And the way we do this is, we start by, on the calculator, finding a root. We know that at least one of these is going to work in this. If we didn't have a calculator, we would just have to guess and check. Plug in 1, see if that is a root, meaning see if that makes the polynomial 0. Plug in -1, see if that makes the polynomial equal 0. Keep plugging in these numbers. I would plug in the integers first, it's easier, until you get a root, right? But it's a whole lot faster, and you're allowed to do this. Just type this into y equals, check the table on the calculator, and if you find an x-intercept, that x value will be a root, all right? In this case, if you check the table, let me just check my notes here, you see that, well, if you change the way the table is set to go by fractions, you'll actually eventually find all 3 of the roots, all right? But that takes a while, and it's hard to know how to set that. So the one obvious root you know from the calculator is -4. Okay. The other 2 roots happen to be 2/5 and -1/2. So if you have the calculator go by the table go by fractions, which I'll show you how to do in class, you might see all of them, but it's going to be kind of annoying to do that every time. I recommend finding an integer root and just working from there. All right. So with respect to -4, if you know -4 is a root, we're now going to essentially divide this cubic polynomial by a factor of x plus 4. Okay, we're going to divide this polynomial by a factor of x plus 4 because we know that negative 4 is a root. So x plus 4 must be a factor. All right? So just to remind you, negative 4 is a root. Then, of course, x plus 4 is a factor. So to do this division, to divide 10x to the third plus 41x squared plus 2x minus 8, to divide that by the factor of x plus 4, which we know is a factor. First of all, we know we're going to get a quadratic quotient, right? Because a cubic divided by a linear, we're going to end up with an x squared, right? A quadratic. Okay, so that'll be our answer, but how to get that answer, I recommend the easiest move would be to do synthetic division, like I showed you in class. We also could do long division. So I don't want to make this video too long. If I have time, I'll show you both, but I will go over both in class. All right, so for sake of time, it's more efficient to use synthetic division, in my opinion. So we put a negative 4 in that sort of half box, and list just the coefficients here, 10, 41, 2, and negative 8. Leave some space here and draw a line. Bring down the 10, and now we multiply by this number in the square. Now we add these two up. Now we multiply. And now we add. And now we multiply. And we add, right? And we get 0. And of course, that's what we get if this number is a root. We will always get 0, right? This number is the remainder. And what we're left with, the quotient, this cubic divided by this linear, is going to be 10x squared plus 1x minus 2 with no remainder, right? This is the quadratic term, this is the linear term, and this is the constant, or just the number, right? And this is the remainder, okay? So that really is very helpful, because now that we know we get 10x squared plus 1x minus 2, remember we already knew that x plus 4 was a factor. Okay, so that's why we did the synthetic division with the negative 4, with that root. Right? But the instructions in letter B were to factor the polynomial. So your answer is going to be, well, x plus 4 was one factor, and this quadratic is the other factor. And just ask yourself, does that quadratic factor further? Well, you have to do that. Everyone has their own way of factoring. Some folks like using the quadratic formula and then going from those solutions to the factors. I think it's just as, it's even quicker just to guess and check here. So let's see. Well, the only way to multiply to 2 would be 1 and 2. So I'll put a 1 and a 2 there. For the 10x squared, we could have 10x and 1x, or 5x and 2x, or 2x and 5x. It's going to be 2x and 5x, okay? Because now, we're forcing the 10x squared, and we're forcing the 2 to happen. But if this is now positive, this is going to be positive 5x. And if this is a negative, that'll be negative 4x, because they've got to add to positive 1x, right? So now we have all of our factors, x plus 4, 2x plus 1, 5x minus 2. And if this quadratic didn't factor, then you would just leave that whole quadratic as one of the factors. Instead of having 3 linear factors, you would just have your linear factor that we used originally, and then the quadratic factor next. All right? But it did factor further. Okay, and if you weren't sure by guessing and checking, then again, as you know, you can use the quadratic formula and see if the roots are rational. And if the roots are rational, you can factor it. All right? So that's the hard part. Right? Of all this stuff we're doing today, listing the possible rational roots is pretty easy. Doing the synthetic division or the long division, and then going further with the quadratic, that takes a little bit of time. All right, but letter C just said find the roots, so now we know the roots without having to do any more work. Negative 4, negative 1/2, and positive 2/5. All right, and your calculator would show that, right? If you had your table go by 1/2 or go by 1/5, then you would see the intercepts. All right, so again, just kind of wanted to go over one example for you in case you missed something from class. There's always some student that messes up with the part A on a test by flipping and doing the factors of the first coefficient over the last one. So be warned, don't let that be you, okay? The potential rational roots are always factors of the last number over factors of the first number. And, all right, actually 3 of these happen to be our roots, right? Okay, peace.